Good afternoon, everyone. My name is Eddy from Samsung Research. So where I'm in charge of Samsung's 6G R&D effort across global research centers, including Samsung Research Seoul, Samsung Research America, Canada, China, India, Poland, UK, Russia, and so on. So first of all, it's my great pleasure to present Samsung's view on 6G. In particular, I'm going to talk about technologies for the next hyper-connected experience for all. That is Samsung's vision for 6G. So in particular, I'm going to introduce recent progress of the Samsung's R&D effort, including some of the POC effort that will be presented later. Yeah, so as addressed by previous presenters, the cellular communication systems has evolved every 10 years on average. In particular, the 5G is supporting the eMBB, URLC, and MMTC that opens up opportunities for a variety of new services. So now, as we know well, we are talking about 6G. So let me start with a quick overview of 6G in various aspects, including vision. Thank you. Yeah, including our vision and some of the key services and the requirement and the key characteristics of 6G. Then actually I'm gonna talk about some of the key 6G enabling technologies. So again, our Samsung's vision on 6G is to provide the next level of the hyper-connected experience to every single corner, where in addition to the proliferation of the advanced services that are already being tried by 5G, we are expecting a few new 6G services or advanced services. To name a few, the true immersive XR and high fidelity mobile hologram and the digital replica that requires much stringent throughput, latency, and also non-communication related features such as localization, the sensing and imaging, and so on. Yeah, then in order to make those advanced services a reality, let me address some of the requirements needed for the 6G systems. First, performance aspect. So we are, generally expecting the, big jump in terms of the traditional KPIs such as capacity, the coverage, latency, energy efficiency, connection density, and so on. Whenever we are designing a new generation system. So in addition to that, basically support of non-data features and services will continue to be required from 5G. So yeah, as I mentioned, sensing, imaging, and localization, in particular with the tighter performance requirement compared to 5G. And in particular, some relevant services, would include like digital replica in the cellular network and so on. In addition, so the network architectural aspect is also quite interesting and important. As the new services requires much higher throughput in general, as well as the heavy computations. So basically, the computations and the computing convergence will be becoming more and more interesting and critical. So, for example, related applications are the split computing and native AI and so on. So, in addition, a kind of non-terrestrial networks. So that has been already explored, but it is expected that 6G will way better support those aspects. That aspect will include satellite and HAPS. I guess many of you are already well aware of. Last but not least, the trustworthiness requirement is also very critical and important. So, today, actually, addressed by our KT presenter. So this is not about that. Yeah. So basically, due to the trend of softwareization and the openness and heavier usage of the data, so this trustworthiness and the security is becoming more and more relevant. Right. Okay, then here, I would like to kind of summarize the key characteristics for 6G system. So first of all, extreme performance, as I mentioned earlier, those are always kind of the advanced in every generation. And then the softwareization involving virtualization and programmability and cloud native attribute and so on, especially thanks to the performance improvement of CPUs. We know that the VRAM is already becoming a major approach for the the commercial deployment. And intelligence, of course, the AI is becoming more and more popular and a powerful tool, not only for the communication, basically all the industry. So we expect the AI will help a lot, in particular reducing the CapEx and OpEx, as well as improvement of the communication system performance. And then the integrated communication and computing, as I mentioned earlier, and sustainability. Actually, our previous presenter, Sungwan Kim from KT, showed a very interesting aspect. So, of course, this energy efficiency and the cost efficiency will become the more critical. Finally, the fusion of the physical and virtual world, actually that is addressed by many people when it comes to 6G. So the digital replica or digital twins is one example of that. Okay, now let me switch gears to enabling technologies of 6G. So here I actually list up various pillars of the 6G technologies. So today, in the interest of time, I will not be able to address all these technologies, but in the later part, I'm going to elaborate a bit more on some of the selected technologies, including our recent progress, R&D progress. So the spectrum, I'm going to address a bit more later, but actually this is always a key driver and the key enablers of the new generations, especially to address substantially increasing the demand of the data traffic. And then when it comes to radio technology, extreme MIMO and the terahertz communication, I'm going to elaborate a bit more in later slide. And the millimeter wave So basically, as presented by previous presenter, the SKT Takiru. So basically, based on the learnings and the lessons from millimeter wave deployment in the 5G. So basically, it is a good opportunity to reconsider or redesign, to facilitate the actually wider usage of this technology and spectrum. And the advanced duplex, such as full duplex or some kind of variant of the full duplex is expected to be more popular in 6G era, I would say. And then the RIS, actually, I'm gonna address later. And then, LOS MIMO to address, in particular, some limitations of the so-called special dimension in the LOS environment is also interesting technology. And joint communication sensing, especially in relation to the digital twins or digital replica. And near-zero energy communications is also interesting. The area that Samsung is exploring, in particular for the applications such as some low-end sensors, and so on. And then waveform coding and modulation is always sort of the core of the physical layer of communication systems. And the energy saving is also critical. So I'm gonna show you some of recent progress on this aspect as well in a later slide. Okay, now the network architecture. So actually, especially Samsung is exploring the areas listed here. So as I mentioned earlier, the communication and computing integration and system for distributed cloud and basically RAN and core converged architecture. That is also another interesting area. Trustworthiness, again, as I mentioned, is also quite critical. To name a few, quantum safety, some resilience aspect, and so on. And AI native features, that is being addressed and emphasized by many people. So basically, AI native attribute and some of the advanced kind of scenarios, such as the split and the federated running, is also being explored by Samsung as well. And green network, cost efficiency, and also the migration from the previous generations to 6G is also always an important aspect when it comes to a new generation. Okay, here is Samsung's view on the spectrum. So as actually illustrated here, from sub-1 gigahertz all the way to so-called sub-terahertz will be used where some of the spectrum range is already used by previous generations, but some of the spectrums will be refarmed and so on. So in particular, new opportunities for 6G will include 10 to 20 gigahertz range. We call it the upper mid band, and the W band and D band, 92 to 114 and 130 to 174 are actually the interesting and new opportunities for 6G. Okay, then in the remaining slide, I'm gonna touch upon a bit more details with some of the videos illustrating our POC effort. First, actually the XMIMO, we call it XMIMO. That is essentially extremely massive MIMO especially targeting operation in upper midband to to address the challenges in propagation environment, right? Compared to lower midband, such as 3.5 gigahertz band, that is actually the global 5G spectrum today. Through the advanced MIMO technologies, so-called, again, the X-MIMO. So in terms of the MIMO dimension, so basically the 10 times, a larger number of the antenna elements. So for example, about 2K or 3K, compared to, let's say, 192. That is basically today's standard in the commercial deployment. And in terms of the TXRU or the digital port, that is actually the number of antennas seen by UEs will become like 256. So compared to the 64, that is actually today's standard or the today's deployment of the state-of-the-art kind of deployment. So that is not actually the simple scale-up. Actually, when we compare or compute the complexity of 256 digital port or TXRU compared to the 64, actually depending on the actual detailed MIMO operation, it will become easily 100 times or a few hundred times. Actually, it is simply impossible to implement. So basically, that is a core of research of this technology. So in particular, actually our design goal of the 6G X-MIMO system is to provide coverage comparable to the 5G C-band, especially to avoid cell densification that, as you know, the substantial increases the CARPEX and OPEX. And when it comes to capacity, we would like to provide a much higher capacity than 5G's C-band. So for example, 20 times, let's say, 4 or 5 times from the increased spectral efficiency, another 4 or 5 times from the, the increased bandwidth. And then the last bullet, actually, that is also one of the important design goals. So as I mentioned, we would like to make it affordable in terms of complexity and energy efficiency. So that is quite a challenging part of this technology. And actually, we are extensively studying this aspect. And terahertz communication, I guess many of you are very familiar with what are the challenges there are. Basically, this particular spectrum is expected to be used for some use cases, not like the traditional cellular or wide area environment, but some local area or or the like some backhaul and so on. In the interest of time, I'm going to address the details of here, but I guess many of you are very familiar with what are the challenges for this technology. And then here we show some of our POC demos. So this is basically showing 12 gigabps communications at 30 meter distance in an indoor environment, involving some of the, a sort of the beam management or beam steering, features. And the next is, so basically they're showing our POC effort addressing the distance challenge. That is a well-known kind of the challenge of, constraint of, the higher spectrum band. So basically, this video shows communication of 1 gigabps at 300 meter distance. Actually, this is a campus in Samsung Research, Dallas. Okay, so another technology that I'm going to address is RIS, right? So basically, we have explored two types of the RIS. One is RIS lens, so that is essentially enhancing the gain and steering range, so located in front of the antennas. And another type is basically so-called RIS reflector. So as illustrated here, that can, that has a potential to address, so-called blockage problem. And in the next slide, so shows some of the details of our, POC environment, in particular focusing on the beam steering when the UE location changes. So the rightmost figure shows kind of so the phase distribution of 2D array of the unit cells. And so the next slide, this slide shows on our lab POC demo. So as you see, we have the actually it involves TX, RX, and the blockage, and RIS reflector, and so on. And as you see, so when we move the receiver, so basically the RIS reflector, phase array is reconfigured without changing actually the physical locations. So that is actually the core part of the RIS technology. Then, yeah, let me switch gears to AI. So that is actually the last part of my presentation today. So let me introduce actually the two aspects. One is so-called AI-based energy saving, and the other is AI-based the receiver algorithm enhancement to address so-called PA impairment. Yeah, the first one is so-called AIES, that is AI energy saving. So essentially, the idea is to turn on and off the cell per the traffic demand there, traffic existence. So this figure illustrates the energy savings by the so-called AIES technology, while keeping the perceived throughput the same. And also, actually, it involves closed loop data collection and the digital twinning and analysis, AI training, and actually optimizing the parameters and so on. And this slide actually shows and comparing, with and without AI-based energy saving. Actually, it shows the performance gain in terms of the power saving, and also in terms of actually the annual electricity cost, using an example. And then the next is actually illustrating some digital twinning, for a particular the actual region. So as you can see here, it is collecting data and pre-processing the data and replicating the scenarios, and actually the modeling AI, and actually the applying the parameters related to cell turning on and off. Okay, so the last thing is called AI-NC. That stands for AI-based nonlinear compensator. Basically, we all know that actually, it is desired to operate in a higher the operating region for a given power amplifier to without much distortion of the signal. So basic idea of this technology is to compensate the nonlinear distortion induced at the transmitter. So based on the AI that actually learns the transmitters, the PA and nonlinearity. So in particular, this technology is powerful to the high order modulation that typically suffers from the nonlinearity. So basically, I have the two video files comparing, traditional scheme without, such a kind of the compensator, AI-based compensator at the receiver. So in this particular example, the coverage or communication range is about 13 meters, but actually by employing the AI NC scheme that I explained earlier, the kind of the coverage can be increased to 25 meters from 13 meters in this particular setup. Okay, so yeah, actually the one thing to more address is our view on the standardization timeline, in particular 3GPP1. Given that ITR has recently agreed upon the timeline to finalize the 6G vision by June next year, and by 2030, the IMT 2030. So basically, in terms of the 3GPP timeline, we are expecting, the first version of the 3GPP specifications of the 6G can be provided by kind of the end of 2028. Okay, so, sorry, actually there is some inconvenient situation with respect to the slide. So let me conclude my talk by addressing the two white papers that Samsung has published recently. So one is 6G white paper, and the other is basically a white paper with respect to 6G spectrum. Okay, thank you for your attention.